In this section we will start complex power series. So we will see complex power series which will help us to explore the properties of analytic function. So begin with power series as an example of analytic function, and we will show that every analytic function can be expressed as a power series around 80 points of analytic function. So now let's start complex sequence. These are the basic word related power series. So it's important to know how utilize complex sequence. A sequence of a complex number is a function fn tends to c. That means assigned to each continuing number there is a complex number, and that was the f1 usually called the first term of the sequence. And example of a complex sequence, that is 1 plus 2i, which 1 is the real number and 2i is the imaginary number, and 2 minus 3i, it's the example of a complex sequence. And convergence is the most important word which used complex power series. And what is convergence? Convergence this means that a complex sequence an which is said to be convergence to a complex number L if for each epsilon greater than 0 and absolute of n minus L less than equal to epsilon which n greater than equals to n. And convergence means that an means n gets larger and the term of the sequence get attributary close to the limit L. And we know fn usually called first term, and we use fn is the nth term of the sequence. A complex sequence is a function from the set of positive integer to the set of complex number. And now we will see Cauchy. What is Cauchy? If for each epsilon greater than 0 there is a corresponding n epsilon element of n such that for any m greater than equals to n and n greater than equals to n epsilon, which is modulus of mm minus an less than equals to epsilon. That means Cauchy is very similar for the real sequence, except that once again absolute value in the case of real number and replaced by modulus of the sequence. And Cauchy condition is very useful to the complex power series. And now complex series. What is complex series? Also complex series is very useful of complex power series. Complex power series which let an be a complex sequence and the sum a1 plus a2 a3 etc. is called the series of series which summation of an, and this series n is said to be convergent to the sum s. If the sequence of partial sum Sn given by Sn equals to a1 a2 n which is sum of aj which is sum of an and convergence to the limit s. And now we will see power series. A series of the form a0 plus a1z and a2z square where ai element of complex number c is called power series around 0 in the variable z. A series of the form which c0 plus c1z minus a plus c2 z minus a square where ci element of complex number is called power series around a in the variable z. And this is the main point. Note that power series around 0 convergence to the 0 for z equals to 0, and the partial sum of the series I s0 equal to n0 and s1 equal to n0 plus a1z, and sn in the term of a0 plus a1z plus a2z square and anzn. In this case we can write s equals to summation of z equals to I to infinite aj. If the sequence Sn does not convergence, then we say the series aj does not convergence. That means so that the set of points convergence is at least non-empty. Okay, but more is true depend the coefficient of a0 or c0. A naught or C naught. What happened? So firstly notice that point, and let's see a example of a power series. This is the term of power series. This is the term of power series and called power series about a point z equals to z naught. If z naught equals to 0, then summation of a n zn. And example, n equals to 1 to infinity zn by n, and n equals to 2 to infinity zn by n log n z. This is the example of power series. And let n be the sequence of complex number. The final sum a1 plus a2 etc. is called the series of an, and the series an is said to be convergence to the sum s if the sequence of a point of a partial sum Sn given by Sn equals to this term convergence to the limit s. In this case, one write s equals to this term of j equals to 1 to infinity as j. If the sequence Sn does not convergence, then we say that the series An does not convergence.